Hey there guys, welcome back to the channel. This is your buddy Shanak, and today we are diving deep into the fascinating world of Sora, our latest text to video generator by OpenAI. This is not a real video. It is generated by Sora, a text to video model by OpenAI. Sora generates high resolution videos with realistic scene dynamics up to just 1 minute. These generated videos have a excellent 3D consistencies and can simulate a lot of things like fluid dynamics, snow particles, and even reflections. Pretty cool, right? First, we'll learn about Sora and what all it can do. Then we'll look at the behind the scenes of Sora and how exactly it was trained to create such amazing videos by text. Then we'll look at some of its use cases and see where exactly it can be used and which all industries it is going to impact. Sora is a tool that changes text into video. When you write something and it can create a video. It can create videos in multiple sizes from 1920 to 1080 like landscape like this, or it can even create portrait videos like 1080 into 1920. Look at the clarity, look at all the interactions, reflections it is able to generate just by our text prompt. Sora can work with pictures also. For instance, it took a picture of this dog in a beret and a black turtleneck and turned it into a realistic looking video. The amazing thing here is Sora understands the images and the context also. It looked at this image and looked at it created a believable story around it and then made the video. It looked at this image of an old hall with huge wave and two surfers and turned it into a stunning video without any trouble. Sora can generate seamless transitions between two videos. For example, it can morph a drone flying over the Colosseum in Rome into a butterfly underwater, seamlessly shifting the surroundings. Look at this was one of the input video and the other video. It seamlessly transitioned the drone into the butterfly. Look at the transition. It transitioned from Rome to underwater very seamlessly. You are not able to see when exactly the transition happened. Sora can actually extend videos forward and backward in time also. Just like in Photoshop, where you can extend an image and let the AI generate the extension part of each and every image. Sora does that in time also. You can input this video and prompt it to extend by number of seconds into the future or in past. Look at the three videos. These three videos, they were all extended backward in time, starting from this specific segment of a generated video. So while each video started out differently, they all ended the same way. But remember, this is where we stood 1 year ago. Keep that in mind as you follow this industry. So Sora uses transformer and diffusion techniques for this. OpenAI team used a lot of different research papers to develop Sora, but visual patches and compression techniques had a big influence. Let's just go slightly into transformers and diffusion so that you have complete understanding of these techniques when we go deep into the space-time patches that OpenAI used for a lot of this video creation. So transformers, which are just heart of language models like GPT, are great at predicting words to create clear sentences. Diffusion, the model used in a lot of platforms that turn text into images like Dolly, Midjourney, and Stable Diffusions, they predict color to create the final image. So now Sora combines both these techniques to predict patches, which ultimately helps in creating videos. The patches is the equivalent of colors and words here. Okay. So now, what exactly transformer does? Just a quick run through. So whenever you gives any such user input saying that how do I start learning to code? Okay. So what exactly encoding does? It simplifies the sentence into its most basic form. For example, the sentence how learn code may not be grammatically correct, but it conveys the same meaning as the original prompt. Each word is then assigned a probability, and we are assigned a vector so that we understand the context and the meaning of the prompt. We then move to the decoding stage. The stage generally involves evaluating the context and predicting the sequence of word for the response. So it evaluated the context, predicted the best sequence of words, and then started creating the words for the response. On the other hand, how exactly diffusion works? Diffusion is generally used in AI art generation. It functions by gradually transforming a fuzzy canvas into an image through prediction of colors and shapes. At its core, diffusion operates repeatedly by adding Gaussian noise to the training data until the image becomes pure Gaussian noise. It then learns to restore that data by reversing this noise addition process. The ultimate goal of training a diffusion model is to learn the reverse process. That's it. So when you put a text prompt into Sora, it uses a tool, it uses the transformer, it makes the prompt into a very detailed video script, including things like camera, texture, animation, and so that the now apple falling from a tree becomes a red apple falling down vertically from the branch of a tree in center of the screen zoomed out. So we gave all different types of parameters so that it creates a detailed prompt for the video creation. This refined script is then used to create a list of spacetime patches. We'll discuss spacetime patches into much more detail shortly. And finally, diffusion turns these patches into a final video. It makes a visually coherent video from the original text prompt. In the past, diffusion models could only make still images. So this made it very hard to create smooth images, smooth videos. As you just saw the AI Will Smith video, it looked very random, very abrupt. The frames couldn't align, the output was very incoherent video. When people tried to join these frames together, there was no sense of physics, motion. So the quality was not at all good. So we'll just go through transform once again so that you can see the analogy of how they use the transformer to create visually coherent videos. So the first step is to was converting the data into form it can understand. So we broke down the user input, we encoded into vectors, and then we added positional data so that it is easier to work with. And we want to keep the word order also. That's why we added the positional encoding also. These are the three things we did. So now for Sora, OpenAI created this method to implement the similar concept to videos. So they converted the raw video into a series of single images. Now these list of images are then cut into smaller pieces, and we call this patches. What exactly patches? Patches are group of pixels in multiple frames. These patches are then transformed into vectors and compressed. You can see this blob of connected pixel. This specific in a group of pixel in different frames, we join them together and we call them as a small patch. Okay. Now Sora tries to understand these sort of similar patches in video, and it tries to predict, saying that similar patches should be represented by similar vectors. This understanding of the model helps the model interpret the purpose of each patches. Every patch has a specific place and time in the video, just like words in a sentence. So to turn the patch into a flow of data, we add the space and time details to them. This process is very similar to how a transformer uses positional information when dealing with natural language. So to summarize, space-time is effectively space-time means animation, and patches is just means a fraction or a piece of video. So space-time patches is what? It's just breaking down a video into smaller pieces to learn how things move in different frames. That's how it is trying to learn to predict animation, and that's how which actually means how to predict change in color. How can we train a model to generate these space-time patches? It's possible that OpenAI prepared a dataset consisting of numerous videos and images, each with a description of occurring event. They they would have used Dolly recaptioning capability to generate description for images and employed GPT to enhance them. Here you can see Sora learned from a lot of videos like paper falling, video falling, notes falling, or fruits falling. So based on all this video, it understood what exactly falling means. Falling just means that it's a downward change in pixel values. And based on that, it understood, okay, falling means this is how we have to change the pixels whenever somebody is writing input prompt as falling. Lots of apple falling if I'm giving as a user input. Sora begins with a fuzzy video using diffusion and spacetime patches. It tries to predict what kind of color changes I have to do so that the fuzzy video is converted into a final video which shows lots of apple falling. OpenAI also talked some new skills of Sora, even though it was not specifically trained for them. One of them is understanding the 3D space of the world. Sora can move, it can make movies with both moving and non-moving objects and a moving camera. All the objects move realistically and are positioned perfectly. In the past, generally when video models often had a lot of problems when objects would vanish and change if another object blocked them. But this is not the problem anymore with Sora here. Now, Sora can actually remember where each and every object is, and it can show the same object from different angles, and it will look the same each and every time. Sora is the deep understanding of real world. It enables it to simulate realistic interactions, such as painting on the canvas or biting a large piece of a burger. You can see this interaction of painting, it can simulate that each and every time this color patch that is coming in, that's the virtue of creating the interactions. Now OpenAI is saying that Sora can understand the world around us deeply and render this an understanding very accurately. This skill is not just for the real world but also for virtual world like Minecraft. Sora can understand the rules of Minecraft's world and can simulate a player moving and interacting in it, just like the actual game. Just look at the so many video games that can be created by just Sora. But now Sora has a lot of limitations also as a simulator. For example, it cannot correctly show the way simple things work. Like look at here the glass breaking. Other actions like eating food also doesn't result in the right changes. It also has a lot of trouble showing the physics of a complex scene correctly. It might not get specific cause and effect scenarios. Just look at this video. For instance, a person also might bite a cookie, but the cookie might not show the bite mark after. Also get mixed up with locations in prompt like confusing left and right. It might also have detailed difficulties with detailed description of events happening over time, such as tracing a particular camera path. look at look at this video of a person running on treadmill backwards. So I've been thinking how Sora might change the way we make videos. Here are some of the areas that I think big changes can happen in video creation space. Some are good opportunities, some could be difficult to implement. So the use of multimodal models will greatly impact several industries like film, TV, live broadcasting, media, anything in 2024. In the art of short videos, Sora can handle all such tasks like filming, directing, editing of short videos single-handed. So let's discuss the impact. The first one is accessibility and entry barrier. Sora could make it easier for more people to join the video creation industry. Instead of buying huge costly instruments, all you need is just a monthly subscription to Sora. Telling stories and selling ideas. Filmmakers now can use text to video tools to create lively storyboards for their script. This could make their ideas clearer when presenting to possible partners or investors. B-roll and stock footage. Sora's ability to create realistic videos from text can make creating B-roll footage easier, reducing the need for a lot of on-site filming. Look at this drone video. It looks so real. Think of all such B-rolls that we can create from OpenAI. Next is the animation and visual effect. Sora's text to video features can be used to create temporary effects as reference for complex CGI shots. Finally, regarding the quality of content, Sora can provide a platform for people to explore video creation and make amazing content. This could help people move away from average content and create their own and huge, making future stories more personal and emotionally rich. Thank you for joining me on this exploration. If you found this video beneficial, don't forget to like, subscribe, and click on the bell for future content notifications. Until next time, this is Shaunak signing off.